Welcome back. This is the last segment. It has been a great day so far. This is just the last mile. We have a few very good presentations around roadmap and hardware and HPC systems and what's next. So this is the future-facing type of, if the rest of the day wasn't, of the systems part of it. So we have a nice set of speakers for this last segment. But before we get into a segment, we have, as I said before, a raffle, and I'll ask a question. So the first one to send the answers using WOVA to Trish, so pull up your cell phones, get your WOVA application ready, and when I'll give you 1 more minute, and when you're ready, I'll ask a question. The first one to send that answer to Trish will get a nice, this is a Amazon Echo Dot. So it's a nice price. Very good. So the question is, what type of keys indices, which 2 types of keys indices did Fabian Fehr try in his research in similarity search? Which 2 types? And maybe I could say that bonus points are which one was faster. You have the question. The first one to send the answer to Trish will get the Echo Dot. We already got one? Okay, now that can't be.
If it's correct.
Yes, it is. Yes, it is. Yes, it is.
Okay. You got it?
Yes. Let me take a look again, just in case, to verify. Just in case. Very good, those 2. Yeah, that's perfect. Okay, very good. Ignacio Calvo, we got the answer then. Very well done. And it was prefix trees and inverted indices. Very good, great. Thank you. Very fast. It's fast typing. Okay, good. So the next segment has someone that has been involved with HPCC for decades and has been core to many of the things. He is synonymous to ECL compiler, and he's Gavin Halliday. And Gavin is not just part of the core group of developers in HPCC and also a deep core compiler writer, but also he's a futuristic type of visionary, always working on what's next, what's beyond the horizon, and preparing the new capabilities for the system. So he will tell us things around the roadmap and what is in the current releases and the future too. So welcome, Gavin Halliday, please. There you are. Good.
Right, hello. I don't know how many of you know, but we actually released version 6.4.2 of the platform last week. So now's a really good time to give you an overview of what's in that product and also look ahead a bit to what might be coming up in 7.0. So I never know quite how to split up these talks. One time we did a talk on how the sort worked, and I think that lost most of the room. So we'll probably go back to some nice themes that we can be woolly about and not too specific. Anyway, so the first of these themes is productivity. So what we always want to do is improve the productivity of the people using the platform. I asked them, we've got about 200 ECL programmers ourselves within risk. So everything we can do to improve their productivity, that's going to really help us develop the products we need. So there are various changes that make life better for ECL programmers. Now, risk is actually, at the moment, going through a has got a bit of a challenge in that historically we haven't used local source code. We've had all the source code stored centrally and retrieved centrally by ECL CC server. And we're migrating from that central source control model to using Git, and it's posed us a couple of challenges. One is that we've been using ECL for about 10 or more years, probably 15 years. So some of our queries are actually quite big. I'd say, so I get bugs in the compiler, not very often, but every now and then. And typically the size of those queries is in the 10 or 20 megabytes of ECL source code. So they're quite big queries. When you've got central servers, they could be nice and beefy and process that. The ECL developers haven't got as powerful machines, and some of those big queries, they struggle a bit more with it. So I'm sure the developers will say that the solution is they need faster computers with more memory, but without that, we've done some things in the platform to target those queries to speed them up. We've improved the compiler speed, and there's also some queries. We've added this kind of experimental option, fast syntax. It changes the way that the queries are represented, but it works some of the time, not all the time. But if it is a query that it helps with, it really helps with it. So basically, and this is going to be ongoing to 7.0, we need to make sure that those big queries will work and you can deploy them from simple developers' machines. You don't need enormous boxes. And the other problem that it's introduced is with our central source system, when you changed a file, you also checked in a copy of the record for that file, and then all the developers using the system would automatically get that most recent version of the record. Now, the problem if you're using Git is a lot of the developers won't have updated their local source code with recent changes. So they'll be working on an old version and somebody else has released another one. So what we've added is the ability to say, actually, this is what I think the record is like, but go and check and get the definitive thing from DALI when the query is compiled on the server. The upshot is that it means that people will be able to keep developing without having to keep synchronizing their source, and your queries will still work efficiently. So we've made other changes in the IDE to improve the usability, and some of the new languages which are used to express higher level concepts like Kel and ESDL, they're now colorized and they're better integrated. So, dynamic ESDL, I did ask what this is, but I've never used it, but we use ESDL for defining the interface for services, and dynamic ESDL is a much more easier system to use. You don't have to compile your definitions and then deploy those to the server. You can just get your definition, upload it, and that will automatically link with the Roxie queries or Java queries you've developed, and it does a lot of the hard work behind the scenes for you. And the ML is just, I'm sure Roger's going to talk about it later on. It's just an example of where we're moving more of the functionality into the core of the system so that it's there ready for you to use. So not just ECL programmers, there are some changes like if you copied a file and then deleted it, you didn't actually have any idea of where that file came from or who the owner is. So now when you copy files, it keeps that history so that you can keep track of that. Tony has added things to make managing packages easier on Roxie. And one of the challenges Risk had was we had some new hardware for a cluster and we needed to migrate all the files over from it. Jake has added functionality to Dali admin to just make that easier. So it's a case of kind of going through, finding things which aren't as easy to do as you'd expect, and then trying to improve them in some way. The error reporting, our ultimate goal is to get it so that the errors clearly point you to what the problem is, and to really help so you don't need to hassle us, not quite, but so that you get an error and you don't sit there going, I have no idea what that means. It points you at the problem and helps you to diagnose it. We know how much you like the MP link error, so we'll leave that in for a while yet, though. So, looking forward, in 7.0, we're planning to improve ECL Watch. In particular, we want to change it so that the really important information is drawn to your attention. So if you've got a problem with your query, or if something's taking too much time, rather than being buried right down deep, we want to bring it right up. Gordon is going to do a talk on visualizations, and it's going to be building on that work and creating dashboards. But also, once there is a problem, we want you to be able to delve down and get a lot more information about what might be causing that problem, and so you can improve any issues with the queries. We're going to, I know the compiler's as fast as it could possibly be, but we might make it even faster. But more seriously, what we want to make it so that syntax checking locally is very quick, so that I think at the moment, especially for LN people, there's quite a pause when you syntax check things. We really want that to be instant so that you're not interrupted in what you're doing. And one of the side effects of that will be to probably improve the context-sensitive help and other things within the ECL IDE or other IDEs like VS Code. So those are some of the changes we're planning on doing. If I skip things, you can ask me about them afterwards. So, we can't do everything in the platform. As we've seen today, there are other packages that we want to integrate, like Couchbase is on this list. In 6.4, we've got embedded support for Couchbase, so you can use that directly in your queries, and support for Python 3 as well. Interestingly, the AWS integration wasn't done by any of our team. It was done by an external person, and you can do the same. If you've got a particular thing that you want to be able to call, a lot of the framework is there, and we'd be very willing to kind of give you help on how to integrate it and what steps you need to go through. And what else? So Richard was playing with TensorFlow and calling that from ECL, and he realized, oh, actually, I need to be able to persist some information from one call to another. So he's extended the embed support to allow you to do that. There's also this thing called compile time embed. So now you can actually call Python code as your query compiles. Now, you might think that's a slightly strange thing to do, but it could be quite powerful if you combine it with the pound expand option in ECL. It means you can use Python to generate ECL, which is then included in your program as it compiles. So it's like we have the template language, but it provides an even more flexible way of generating ECL. And it's not just us using other things. So the SQL, WSSQL allows you to access the HPCC files from things that understand SQL, and that's had improvements in the caching and support for wildcarding and things like that. Going ahead, we still want to do more. I mean, hands up if you know what Spark is. Okay, reasonable number in the audience. So I think in fact it's quite complementary to HPCC. It's got, internally we quite like to use it on some of our data because it has ML algorithms that we haven't yet got in our ML libraries. And so some of the work we're doing in 7.0 is to make it so that you can directly access HPCC data files from Spark. Now, I know there was a poster presentation about some work that's been done on that. We want to make it much better so that all the files are accessed in parallel, and you can almost use it as though those data files were native to Spark. And some of these things we're not sure if we're doing. There have already been some Unicode changes included in the 7.0, and I suspect there'll be some more. So, performance. I think we actually spend quite a lot of, what was I going to say? That we enjoy tackling performance problems, so we enjoy finding them and then working out good ways of speeding them up. Quite a lot of these come up that we're looking at a particular problem and we spot something and think, that's not right. And so, for example, we've done some work in the way that XML is read by the whole system, but it's actually used quite a lot in Roxie. And especially when you had lots of concurrent queries, that could be quite slow. So that will be quite a lot quicker in 6.4. And yeah, we've been trying the system on new platforms. So I ran the system on a Knight's Landing system, which it's got, I think, 72 cores, each of which can run 4 threads at once. And that posed some challenges, but just making sure that it works well on that environment. And John is going to talk later about new ways of, or plans for how we use Roxie. And when we tried it on that, we also found some issues which we've tackled. So, more of the same. We've got plans for improving XML for the memory manager, which is used by all the engines, and speeding up Thor. It's worth probably pointing out the remote file operation. So at the moment, there are occasions where one Thor cluster will read data from another Thor cluster. And quite often, it's not all the data, it's a small proportion of it, and you don't actually want all the fields. So what we're hoping to do is to be able to execute filters and projects on the cluster with the data, so that only a small amount of data is actually sent back. So that should have the effect of greatly reducing the network traffic and speeding up the whole process. And a similar thing can be used for key joins that will hopefully improve the performance in Thor of key joins. So, with the recent news about Equifax, this has gone even higher up the agenda if that was possible. I mean, it's always been up there. So I think in the past we've treated the system as a black box that you need to protect all access into the system, but within the system it's safe and you don't need to worry too much about security. And that isn't really true anymore. So we need to make sure everything we already do ensure things are encrypted at rest, but say you've got one Thor cluster reading from another one, we need to make sure that that traffic is possible to be encrypted so it can't be intercepted. So just making sure that you can make the system as safe as you want it to be. So there are some systems where the data doesn't matter and you don't need security, but if you've got identifiable data and it does matter, then doing that. And another thing that's been added is, at the moment you kind of have access to files, yes or no, but there's no way of restricting how files are used. So it's possible now to say, I can only access files from ECL which has been signed by a particular key, and so you can define a well-defined interface for accessing those files to prevent ECL developers misusing those files or something like that. So if you need to tie down access to your data, we're providing more ways of actually doing that. And last of all, reliability. And this isn't actually changes to the platform, but it isn't any good if we come up with lots of new features all the time and make it really fast if you use it and it crashes on you or doesn't work or gives you bad results. So we need to make sure that the platform really is reliable. So there are a large number of fixes in 6.4 over 6.2. I meant to go and count them, but I didn't. But I'm sure it will be several hundred. I thought it'd be interesting to talk about the major minor point versioning. So I don't know if you know, we have, so 6.4.2, 6.4.2 is our version number, 6 is the major number. When that increases, we will typically change some of the functionality in the system quite substantially. So for example, in 5.0, ECL watch changed, and from the old way to a completely new way of doing it. So it's going to be a radical change, and it may require you to change how you do some things. If it's a minor point release, then there will be substantial pieces of functionality in there, but it's not likely to cause you problems. If you've got Roxie queries, you're going to have to recompile them probably, but it will still work. Now, the thing is, I want to underline the thing about point releases. So point releases are just for bug fixes. And in fact, we apply stricter criteria than that. It has to be a bug fix that doesn't change how a query would run. So for example, if we find a bug in dedupe that means it's accidentally letting through too many records, something like that, we wouldn't fix it in a point release. And the point is that we want users to be sure that they can take the most recent point release and it's not going to change their queries at all. So effectively, everyone should be on the latest point release. And there are some other things we've been doing recently to make sure that we do fix bugs and find them. So every time somebody submits a change to the system, it goes through a smoke test which compiles it, runs a regression suite, runs the unit tests. Even before it's included in our system, it's gone through those checks. I don't know if you've heard of Coverity. It's a static analysis tool which is free to use if you're an open source platform. We've been using that. We submit our new platforms every week, and it comes back with a list of things, and that's been very good at finding the odd bug that's got through code reviews, and we've been able to fix problems before they've turned up. And we've got a regression suite which is checking for problems, but also we've got a performance suite. And it's producing things like this. So as you can see at this initial time, the red line is the time for Thor. It's all over the place. And then later on it settles down. And when we were looking at this graph before it settled down, we realized that this was a problem in, I think, the hash aggregate in Thor, that in some circumstances it was hitting bad conditions. So that got fixed, and now the performance is a lot more stable. And we're doing that for all the queries to kind of make sure that we don't introduce performance regressions. So I'm out of time, but if you've got any questions, just come and get one of us afterwards. And yeah.
Very good talk. Always I like to get a glimpse of what the core development team is doing and how they are thinking. Now, but I don't know if you feel the same way I feel in this case, but why would you include an option that says fast syntax check? Is that because you would always want slow syntax check unless you are in a hurry? So, well, I don't know. I'm not, I see Richard coming after me, so no. Just a joke. Okay, good. But once we make that the default, we should include an option for a slow syntax check for those that are masochists and want that. Anyway, good. Now we have a good talk about pretty things. So, and for this, nothing better than someone that represents the pretty face of the HPCC systems team. And not because he's pretty, particularly, I wouldn't say, but it's because he's the one behind all of the front-end interfaces, all of the nice graphics and visualizations across HPCC, and has been doing a lot of progress over the last 2 or 3 years in getting the data representations on the front end on what the user wants to get in a way that is far more attractive, amenable, and that can be even embedded into visualizations for online products directly without needing to recode them into some other framework. So for this, I want to welcome Gordon Smith to our stage. Gordon. Very good.
Thank you, Flavio. Yes, I'm of the opinion slow and steady wins the race. Leave that fast syntax alone. Okay, a visualization update. Where are we at and where are we going? Just in case anybody doesn't know, the visualization framework is a JavaScript library which makes visualizing and dashboarding data on the HPCC platform a relatively easy task. It's relatively easy if you're a web developer, and it's probably relatively hard if you're not. So where are we at the moment? We currently just released version 1.18. We have a maintenance release of 1.16.4, and we're still in and around version 1 of the Visualizer bundle. The Visualizer bundle, by the way, in case you don't know, is an ECL bundle, which allows you to define visualizations and dashboards directly within the ECL language. And when you submit those jobs, it will inject the dashboard into the work unit, which you can then render within ECL Watch or within your own web applications. So where are we going? We're on the road to 2.0. It's planned or scheduled to be released vaguely in tandem with the next major platform release. So that's probably early next year at some point. The major changes in 2.0 are mostly under the covers, so not quite all the pretty stuff which Flavio was alluding to. But they are reasonably significant, and we are doing them for a reason. The first big refactor is we're switching from JavaScript to TypeScript. TypeScript brings strict type checking to the JavaScript language. It's a superset. It also introduces a proper compiler to the language, which means we finally get syntax errors, which allows us to do these big refactoring exercises safe in the knowledge that we have propagated all the changes right through the platform. It has a bunch of other side effects. It's going to give us better auto-completing and stuff like that. It can target some of the common module paradigms that are out there now. So without getting to the technicalities of these, you can read these three as being, it will just work with Node.js. It will just work AMD is the asynchronous module mode, and which means it will just work with our existing interfaces. And ES6 is the future. It's kind of like the next generation of the JavaScript module definitions. The second big refactor we have done is we've migrated from D3 version 3 to D3 version 4. D3 is a visualization library. It's not really a visualization library. It abstracts the way you can join data to visualizations which are rendered within your web page. We use it everywhere in our custom visualizations, and this migration from V3 to V4 was a non-trivial task. We had to touch pretty much every single custom visualization we had to either a smaller or greater degree, but that's behind us now. The next refactor is we moved from Bower to the Node package manager. We use these package managers to manage our third-party dependencies. And it allows us to say, well, we're dependent on this library at this version. And it's kind of akin to apt-get in Linux world. Finally, how we build our own packages. Previously, we used Require.js to generate AMD packages, but now we are Rollup.js, Webpack, and Require.js compatible. And then the final refactor is we have introduced a new namespace, HPCC.js, and the visualization framework is now simply a part of this new, bigger ecosystem. And if we have a quick look at what that ecosystem looks like today, as of September. What we have here is all the green items are essentially the visualization packages that we already had in the old framework. All the black ones are new packages. Some of them are visualization related, some of them are not. But if I was to call out a few of them, we have a new package for timeline visualizations in the works. We've got a React and a p-React packages that will allow us to write new widgets based on the React library. We've got a new grid in the works. It's actually a wrapper around the same grid we have in ECL Watch. CodeMirror is a code editor. It's the same one we use in the ECL Playground. So it's now being moved into the visualization framework so that we can reuse it in other places. So what was the motivation to doing this big refactor? Well, it all started with we wanted to introduce a new standalone package which wrapped around all our communication calls between the JavaScript clients and the platform. So all our work unit management stuff, creating a work unit, monitoring it, seeing when it fails, seeing when it succeeds, being able to get data out of it, being able to call Roxie queries, that whole chunk of functionality was sort of, we had a nice version in the visualization framework, and we had a more mature version in ECL Watch. So what we've done is we've taken the capability of both of those, and we've brought them into a brand new, modern, standalone package, which can be reused within the visualization framework. It already is. And by the time the 7.0 platform rolls out, it will have replaced the communication layer within ECL Watch. The benefit of doing that is we now can use that in other projects. And I've got 3 examples of that here. And I've got a couple of little video clips, because I thought there was going to be a video competition this year, but apparently not. So nonetheless, I have 3 entries. They're going to be pretty quick, so I'll try and keep up with them. The first one is a brand new ECL extension for the VS Code IDE. VS Code is sort of the new kid on the block in extensible code editors. It runs on Windows, Linux, and OS X. I use it a lot. It's really, really good. So if you can roll the first video. When you open VS Code, it looks like that. When you click on the extension marketplace, type in ECL. What will come to the top of the list is the ECL extension. You can just install it. Once you do, you can open up a folder which contains ECL. Open up your ECL file. Off it goes. It'll syntax check. Oh no, I have a syntax error. Come down. Oh, typical typo. So I'll fix that. Any other syntax errors? I'll eyeball that. Then once I go ahead and save it, it'll do another syntax check. And good, we're clear to go. We've pre-configured this with the launch configuration. I'm going to send this to a Thor on my local host. Down in the box there, you can see it's done the usual work unit lifecycle thing. It's spat out an URL. But if we go into ECL Watch, refresh it, there's the work unit from it. And now we can go ahead and look at the outputs from it. So there's a bit of a sneak peek on some of the new ECL Watch look and feel as part of that. The next demo, which is even shorter, is the Jupyter Notebook integration. And again, well, Jupyter Notebook is a sort of a technical article writer where you can do live coding within these published documents and actually execute code, get result sets, and move it on to the next one. We're in really early days with it, and by we, I mean Ming has been working on it. Ming Wang, hands up. Yeah, so Ming has been doing all the work on this, but he's been reusing the new communications package for doing all the submitting to the platform. So if you can roll the second video there. And I'm not an expert on, so we've got a vanilla Jupyter instance here. We're going to open up a notebook. This is a really simple demo. We have a comment block there which says which HPCC platform we want to connect to. Then we can go ahead and we can add an ECL cell. And the obvious thing then is to enter some ECL, submit it, and bang, the results should show up at the bottom. Finally, the last video sort of brings a lot of all of this stuff together. We're in the process of developing a brand new dashboard designer. And if you roll that video, I'll just try and keep up with it. So you start off with a blank sheet, add a visualization. We have to pick a data source. In this case, we're going to pick a logical file. It's gone off. It's pulled down a sample set of the records from that logical file. We're going to do a group by on it. We're going to group by state. That's nice. We're going to do a computed field. We're going to do a row count on it. We could have done a mean or a sum. In this case, we do a row count. We're going to now sort it. So we'll sort that based on the rows, and we'll do that a descending sort. Let's add another visualization. This time, we're going to get oh, no, we're going to move it into the right place, first of all. We're going to pick its data source. It's going to come from a work unit, so it's result 1 from this work unit. Again, we're going to do another group up. This time, we're going to do it on gender. It will just do a simple row count on this one as well. There we go. That's very nice. Let's add another visualization. This time, it's going to the same data source. Actually, we're going to pull the same result set as we did for the Viz4. But this time, we want to filter its content based on the user selection of the first 2 visualizations. So we've picked Viz3, and now we have to align the state selection from that one to the state field in the visualization. We do exactly the same thing for gender, pick gender, and we line that up with the gender. We have equals there, but it could be greater than, less than, etc. So now as you pick your selections there, you saw it filter out. Another visualization. This time it's going to come from a Roxie service. Now we're getting exciting. This time it's got input requests. So which selection we're going to get it from Viz5. We're going to line up person ID to the input of person ID. And now we're actually making live Roxie queries there. Let's add some visualizations. Let's switch that table to be a choropleth. Very nice. Let's switch this one to be a bubble chart. Now we'll leave the middle one as being a table because that's useful. But this bottom one here, what we want to do now is map some of the existing fields so that it'll fit into a multi-line chart. So we're going to do computed fields or count. We're going to say we're going to be equal. This is all sample data, demo data. We're going to add another computed field. This time what we want is the balance. So we have to go through and we pick that on the list. It's in there somewhere. Come on, Gordon, you'll find it. It's near the bottom. Yes. And we'll pick just another column, which is the high credit score. So again, it's going to be equal. It's got to be right there. Yes. Well done. So we're going to trim away the non-computed fields. We've got the data now in the shape we want, so we can switch that to being a line chart. Bingo. And it's all interactive and ready to go. So what do we do with that? That's only a description. That's a description of a dashboard. So what do we do with that? We create an internal data structure we call a DDL. That will either feed into DSP to end up in part of the whole DSP process, or we'll just run it through a HPCC generation. And what HPCC can do at that point is it can automatically create indexes based on that definition of the dashboard. It can create the indexes and publish a Roxie query, which in turn will drive the same dashboard, but at this stage, you'll be able to drive it with genuinely big data. And that's pretty much it. Some links if anybody is interested. And got about 5 minutes for questions. I'm out of here.
Thank you very much, Gordon. This is great. So, how many of you have seen Gordon on stage before in some other presentation? Can you raise your hands? Some of you have, right? So many of you probably saw him showing some of the things that he does. And he makes everything look so easy. He shows you that dashboard builder, new dashboard builder, and he shows you how in, 20 seconds, and even looking for the files, he can get a great dashboard there. Now, how many of you have tried to do what Gordon did afterwards and not getting anywhere close to that? So some of you have, right? Yeah, so we are going to pack not just this in the bundle, but also a little Gordon inside, so he can help you with these things. Anyway, so we're getting close to the end of these sessions, but we have still a couple of very good pieces of content. One, and this is the next speaker, this is Roger Dev speaking about our machine learning library. This is the ECL machine learning library built on ECL natively and designed for a very good performance to tackle a number of the cases that we think are quite common across the needs in people using HPCC and ECL today. So without more preamble, let's welcome Roger Dev to the stage. Roger.
Where's the clicker?
It's on the
Okay. Hi, I work for the Platform Machine Learning Group with Dr. John Holt. And I'm going to be talking about the advances we've made in the past year in machine learning. But first, for those who are new to machine learning, I wanted to do a quick intro to machine learning. This may be the fastest machine learning course ever. And I hope to give you enough to be dangerous, because between now and next year, I'd like everyone to try machine learning on some problem that's of interest to you. So here comes the mini intro. All right, so there are several different types of machine learning. There's supervised, unsupervised, there's reinforcement learning, there's deep learning, which is kind of a hybrid. We're going to be talking about supervised learning today. All of the machine learning methods we've implemented this year are of the supervised type, and that's by far the most commonly used form of machine learning. So here we go. The concept of supervised learning is extremely simple. Given a set of data samples, which we call our independent variables, and a set of target values, which we call our dependent variables, learn how to predict the target values for new samples that haven't been presented before. So I'm going to feed you some of this terminology so that to demystify the whole thing. The set of independent and dependent data together is called the training set. That's what you present to the machine learning algorithm. What you get back is called a model, and that's the encapsulated learning that that method has produced. Each model represents a hypothesis about how your independent data relates to your dependent data. And the hallmark of machine learning, what separates it from other fields, is the ability to generalize. It's no good to be able to say, here's the sample, here's the answer, okay, here's the same sample, give me the answer. That's not machine learning, that's rote learning. Machine learning, you give it a new sample that it's never seen before, and it produces a reasonable answer, hopefully. So here's an example. I've got data here about trees in a forest. I've got the height, the diameter, the altitude, the rainfall, and the age of the tree. So I want to learn a model that can approximate the age, which is the dependent variable, given the other variables. If you look at the data, it's kind of hard to see how you would come up with such a model. It doesn't quite correlate. But machine learning, that's what the machine learning algorithms are good at, is for discovering those relationships. So it will automatically construct a model that does that mapping by minimizing some sort of prediction error. And depending on the algorithm, that error can be different things. So in the process, you may also get some insight into those relationships. Not only will it give you a model that can predict new values, but certain algorithms give you insight into those. We normally want to map easy to measure, or what we call observed features, to hard to measure features. So I could have used height, altitude, rainfall, and age to predict the diameter of the tree, but now I have to cut the tree down and count the rings in order to calculate the diameter, when I could have just measured it with a ruler. So usually going from things that are easy to observe to things that are hard to observe. Two major forms, qualitative models and quantitative models. So quantitative example, determine the numerical age of a tree. Qualitative, determine the species of the tree, determine if the tree is healthy or not. And when we learn a quantitative model, it's called regression. And don't try to figure out why it's called regression. It's a historical fact, and it doesn't make much sense when you think about it. Learning a qualitative model is called classification. that makes perfect sense. You're trying to determine which class a particular data point represents. So there's a bunch of machine learning algorithms. You've heard of all the different names, but they all do pretty much the same thing: classification or regression. And each algorithm has limitations on the type of model it can produce. The space of all the possible models that an algorithm can produce is called its hypothesis set, or the hypothesis space. One of the most common ones is a linear model. You assume that the dependent variable is a function of the independent variables times coefficient. Another popular type are tree models. You assume that the dependent variable can be determined by asking a hierarchical set of questions. Is a height greater than 50 feet? Is rainfall greater than 11 inches? And it must be 65 years old. Some other models, neural nets, provide models that are difficult to explain. You can't verbally explain them. You can mathematically explain them, but it doesn't help. And so those are not considered explanatory models. I want to emphasize that when people first start experimenting with machine learning, they want to pick the latest and greatest algorithm, the one that's going to give you the most power to discriminate your class. But linear models are very powerful things in themselves, because not only do they give you a model that works in a lot of cases, but they also give you a model that with very good explanatory power and the ability to test those hypotheses statistically. So don't dismiss linear models and automatically go to the latest thing. There are good reasons for that, and I will tell you a story in a few minutes that will illustrate that. So to summarize, machine learning is fun and easy. Anybody can do it. Invoking one of the algorithms is very simple. You got your data, you got your target results, you say, give me a model. Now you take that model and say, here's some new data. Using that model, predict the dependent values. If you have some data, you should give it a try. It will provide lots of good insights, may identify some significant possibilities for adding value to your data. Something that anybody can do. But as the professor pointed out during the panel session, machine learning is also very dangerous, and not just because of robot death rays. Also, it's dangerous because there are lots and lots of ways to produce inaccurate and misleading predictions. You can ask bad questions. Given yesterday's temperature, tell me tomorrow's stock close. It will give you an answer. It will not be a very good answer. And there's lots of ways to get bad answers out of machine learning. Bad data, missing values, incorrect values, wrong assumptions versus the chosen algorithm, lots and lots of ways. And I'm sure it would take several courses to learn all the different ways that you can go wrong with machine learning. But it almost always provides you insight when you run it. So always consult a qualified data scientist or somebody that really understands the pitfalls before trying to apply your model to production activity, especially if that has to do with the integrity of the space shuttle or a problem like that. Okay, so here comes a story. This is the true story of Archimedes, and it's a cautionary tale. Now, I'm not a math historian, so please don't hold me to every detail of the story, but this is the way I understand it happened. So this is an actual photo of Archimedes working on the problem of mapping the diameter of a circle to its area. Now, those were the early days of machine learning, and all he had available was linear regression, which he ran on his old Silicon Graphics machine, which was stylus operated. Now, the reason he's holding his head is this. He drew a bunch of circles. He measured the diameters. That was his independent data. And then he roughly calculated the area of those circles. He laid down coins, calculated the area, and he ran his linear regression from the diameter to the area, and he got a reasonable looking coefficient. So that was good until he drew a few more circles, a smaller one and a slightly bigger one, and that coefficient didn't work anymore. So Archimedes, being a smart guy, said, what if I change my data space? What if I increase the dimensionality of my data? So he said, I'm going to try to map diameter, diameter squared, and diameter cubed to my area. And what happened? He found that diameter had a very small coefficient when he ran his linear regression. Diameter cubed had a very small coefficient, almost 0. But diameter square had a pretty reasonable looking coefficient. And no matter which size circles he tried, that coefficient actually worked. Turned out to be pi over 4. So that would have been fine. And that was actually when he said, Eureka, he had solved the problem. But his students, they're kind of quarrelsome. And they kept bugging him to try it on bigger and bigger circles, thinking, well, maybe it doesn't work for every circle. And you know why that was a problem? His silicon graphics was not well suited for big data problems. So now the cautionary part of the tale. So if he had been born a few years later, he probably would have gone straight to boosted trees, which is all the rage at that point. And he probably would have gotten a model that predicted the area of any circle he tried. And in that case, we may never have discovered pi. And that is the value of explanatory models. So remember this story. It illustrates a lot of the points. And that is the mini course on machine learning, just enough to make you dangerous. All right, so now I'm going to talk about the current machine learning bundles and the approaches for machine learning on HPCC. So there are 3 approaches. One is we have an experimental bundle called ECL-ML. ECL-ML has a whole bunch of different algorithms. Many of the popular algorithms are there for all different types of machine learning. But there are different levels of quality, performance, and documentation. So they're great for experimentation, and I encourage everybody to try them. Recently, one of the interns has added a gradient boosted tree, George Matthew, who got an award earlier. Congratulations. Now, I just found out that George developed the gradient boosted trees while he was developing his other project for the poster. So he actually did 2 major projects this summer. Congratulations, George. So second method is you can use our embedded language to support to use any of the industry tools, or many of the industry tools, various R packages, scikit-learn in Python, a pretty robust machine learning package, or Google TensorFlow using Python. The third way is our production bundles, and this is what we've been doing, spending most of the time on over the past year. Producing a set of bundles, and for those of you who haven't used bundles on HPCC, it's a wonderful facility. It lets you add on, it's like adding apps to HPCC. On top of the platform, you can bring in bundles. They install instantly, and they provide independent packages that can run on top of HPCC. So these are the bundles that we've gotten so far. First one is ML Core. This provides all the basic data types for and data analysis methods, math routines and such for machine learning. It also includes methods to convert between your record-oriented data and the matrix form used by machine learning algorithms. And all the other ML bundles are dependent on this one. PBBLAST is the second one. That's parallel block basic linear algebra subsystem, which is basically a way of handling large matrix operations on an HPCC system. breaks up the matrices into many small pieces, and solves those small pieces, brings them back together, uses the full distribution power of the HPCC. Now, all of our machine learning algorithms, all the new bundles, support a capability called Myriad, which Gavin referred to. And Myriad allows you to do many operations, many independent operations at the same time to fully utilize your cluster. So suppose I wanted to multiply 10 matrices by 10 other matrices and get 10 results. I can do that in one operation, which lets you run across the cluster in parallel and gives you optimal performance. So the next package is linear regression. Same package that Archimedes used, by the way. And it provides some nice features. It allows multiple dependent variables as well as multiple independent variables. So you can solve on the same data, you can solve many predictions at the same time. Provides a range of analytic methods for understanding the results, determining if your results are statistically significant and such. It can be useful for testing hypotheses about the relationships between your data. Logistic regression, don't believe it, it's not regression, it's classification. Another historical term that you just have to ignore and know that logistic regression is about classification. It provides binomial, yes-no type classification, as well as multinomial using the softmax capability. It also allows multiple dependent and independent variables, and it includes its own set of analytical methods. Fourth bundle is support vector machines. These are very powerful quasi-linear method that is useful for classification or regression. Under the hood, it uses the popular libsvm library. Now, SVMs are good for problems that don't have a tremendous amount of data, some number of thousands of observations. It does fine for. It does a very good job of separating classes and for regression. And it includes an automatic parallelized grid search to find the best regularization parameters. What that means is it tunes itself, it fine-tunes itself, so that when you ask for a model, it's already had its parameters tuned to produce an effective model. The next one is a general linear model. We talked about linear models. Don't dismiss linear models. Very powerful and very useful in the insurance space. What this does is this uses different assumptions. Lets you decide what type of assumptions you want to make about the shape of your data. So it includes all different kinds of different distributions that your data might have. And it can be readily adapted to other error distributions that we do not yet support. This also includes analytics, and it allows you to have user-defined observation weights to fine-tune the algorithm. And finally, learning trees. The current version of learning trees supports random forests. If you think of a decision tree is like a flow chart that finally results in an answer at the end of your flow chart. Random forests are basically a whole bunch of diverse trees, essentially a forest of decision trees that each is a little bit different. And so it averages the results from all those trees and gives you a pretty good result most of the time. This is known as one of the best out-of-box machine learning methods. Generally, you don't have to adjust any parameters. You just run it, and it produces a pretty reasonable result. It's a black box result, not completely opaque like a neural network, but very difficult to understand because you have to look at all the decisions that all the trees have made to try to understand it. But it's resistant to overfitting. It's capable of dealing with large numbers of independent variables. and it provides a feature importance metric so that you can feed it 1,000 variables, and it'll tell you which ones were the most important in predicting your dependent variable. Later versions of this package will support single decision trees and gradient boosting trees as well. We'll take George's work and bring it into the production bundle. That's all I have. Looks like I'm out of time. You can catch me with any questions privately, and thank you very much. Thank you.
That was a very good presentation. Roger is always very clear, and it was a good way to see what we have right now in place and what is coming down the road in that field too. So that's good. And of course, there is also all the effort around the integration with Spark and supporting machine learning libraries from other systems that also Gavin alluded to that. Well, and now we have the last talk of the day. This is just to close, I think, with another bang. We have John Berger, who has been involved with HPCC for, I don't know, for as long as HPCC existed. And he's been always looking to push the boundaries around hardware and systems and configuration and infrastructure around HPCC and challenging HPCC developers, getting new features into the system, getting them to truly drive some of the efforts around performance in new platforms and some of the things that Gavin has been working on. They've been in collaboration with John, certainly. So he'll talk about the new things coming down the things that we have now and the new things coming down the road around systems configuration, architecture, and infrastructure. And without more preamble, then let's welcome John Berger to the stage. John.
Hi. Well, as Flavio mentioned, my name is John Berger. I get the privilege of being the last presenter standing between everyone and freedom. So I'll take that seriously with my time. So how many of you were in the dinner last night? Raise the hands. Oh, okay, so fair number of you. Well, I thought the high school presentation from the American Heritage had a lot of parallels to HPCC. HPCC is kind of my golf cart. A little bit, right? And just like the individuals that were just up here on stage were a lot like the programmer student that was on there, whereas I'm more the guy that puts on the lift kit and the spinner wheels on the golf cart. So with that said, we'll go ahead and go into some of the innovations and things that we're doing from a hardware perspective in HPCC, trying to progress the technology from a hardware and architecture perspective. So we're going to talk about three different things, three different areas. One's called Hive 360, which is really around the AWS architecture. After the presentation from North Carolina today, I'll call it yet another HAAS on there. We've got Ultra Thor 2.0, which is around the new Thor architecture that we've got in place in our data centers, and something new that's coming up that's in POC right now called Roxie Fusion. So first, we'll talk about Hive 360, and it's a new way to do HPC systems on public cloud. So when we started looking at the HPCC architecture, and North Carolina kind of took a little thunder here, is we saw the same things that they did. Technology, the industry as a whole is moving towards cloud technology. I don't think that that's a shock to anyone in the room. But when we started taking a look at the way cloud architectures are done versus the way traditional architectures are done, these are some of the things that we started to notice where there are some differences between what they're doing on cloud and what you're doing in a traditional data center. And I don't think this is unique to HPCC. I think that this is any kind of software that's coming from kind of that legacy client server model into a cloud-based architecture. But we wanted to look to see, can we do HPCC with resources on demand? Can we have it automatically scale? Can we have it be active high availability across multiple data centers at the same time? Can we have an agile, continuous integration, continuous delivery workflow? Can it self-heal? Can it fix itself? Can we do it in an infrastructure as a service and a platform as a service architecture? And can we lower the cost of entry on HPCC for cloud architectures? So kind of set about taking a look at that. And what we did was I took a look at it and said, maybe I need to break some of the paradigms that we've traditionally used that may have been locking us into more of a client server architecture. So one of the things that we did was we separated the data from the compute plane, because if you take the data away from where the compute plane is, then you have the potential to scale the compute plane separately than the data architecture itself. And that's a key tenet of what we did here. So the second is automatic self-configuration. Can we get it to automatically configure itself and reconfigure itself when you're starting to do things like scale it up, scale it back, and even going to the point of doing auto-scaling, and to the point where it actually scales based on some sort of setting, load, CPU, et cetera. So the other thing is being able to leverage built-in AWS services like auto-scaling groups, elastic load balancing, EFS, leveraging off-instance logs and metrics, being able to get the metrics off. Because if you think about it from a cloud perspective, and those of you that are familiar with cloud, there's this notion of things being ephemeral, the instances being ephemeral, meaning that they can go away at any time. And if you're doing things like auto-scaling, by its nature, they're going away all the time. They're scaling up during the day, potentially when you have load. They're scaling back when you don't have load. And you have to do things like get your logs off the system. You have to get them moved off to a log collection agent where it's indexing them. And you have to get the metrics, how was that performing during that time? You have to get that off the system as well. Part of breaking the clustered Roxie paradigm, allowing Roxie to be able to be auto-scaled up and down based on load, and being able to have it all be API driven, or have the capability of being API driven, so it can be plugged into a continuous integration, continuous delivery pipeline. So when you think about that, you think about things like, okay, we've got a lot of use cases where we've got customers dropping off data files to us. We then ingest those data files into a Thor system and maybe do some sort of batch processing on them, and then we may deliver them back to the customer. That's a pretty normal use case for us. Well, in that particular case, you may want to have a Thor of a certain size process that data file, and it may be based on the size of your input that you're getting in, because you may not need a 300 node cluster to do a very small job, but if you're getting in a job that's got 18, 20 billion records, you may need to produce a Thor that's of a certain size, and being able to call on that through an API-driven infrastructure is very important. So we created something called Hive 360. I admit that the North Carolina guys have a little bit better name than I do for this, but hey, I'm not a marketing guy. So so what we did was we created a CloudFormation template to basically do this, and this is available right now on our internal GitLab library, and I believe Arjuna can get access to anybody that wants it. But it's got a couple of parameters. It's built around an EFS, and I know North Carolina talked a little bit about the EFS infrastructure, and they chose to kind of go after an S3 backed file system where they're moving data in and off of EBS volumes, and because of cost measures. Well, one of the principles of this is even though EFS does cost more from an individual gig, cost per gig standpoint, it's 30 cents versus a 10 cents per month charge for EBS. The difference here is that within the system, there's not duplication of data. And that's very important to understand, because anytime you have a high availability system, you've got a system that you're wanting to perform for customers and it's in production and that type of stuff, you can't get by with just one copy of data in most cases. So your Thor's got a mirror on it. when you have a dev system, that may have a copy of that data on it. So now you've duplicated it again. When you have multiple Roxie systems, each one of those has a mirror on it, and so you've got duplication of data across all of those. And if you separate all of those data pieces out and you do them on individual block devices, well, now all the copies of data, you're doing 10 cents a piece for each one of those copies, and all of a sudden you're way over the 30-cent mark for the EFS file system, where EFS allows you to be able to provide, in the way that we did, it allows you to provide a way to have just a single copy, a redundant copy, but a single copy of that data and multiple inodes or pointers pointing to that data. So one of the things that it does is it runs the HPCC, both Thor and Roxie, and for that matter, the admin services, across multiple availability zones within AWS. That's multiple data centers within an AWS region. And it runs active-active at the same time. So even if an entire AWS data center goes down within that region, the system will self-heal and come back up and running. In the case of Roxie, your customers would never go down. In the case of Thor, that job that you're running at that time might actually stop, but within it takes about 3 minutes or so, it will have fixed itself and the Thor will be back up and running and you can continue to run on that. So that's a very, very interesting feature of this. The other thing is you get instant Roxie data releases. Because we're not making copies of the data going between Thor and Roxie, what we're actually doing is we're creating secondary inode pointers to the data that's on the Thor. So anytime a file gets created on Thor, a secondary inode gets created within the Roxie directory on this. At the time that you release data into Roxie or give it a package file, there's no copying that has to occur. It basically ingests the package file, takes a look, says, hey, I already have the data, and you're up and running inside of your Roxie. So you're not having to push that data out across the network off to a different set of block devices, which, for fast updates of data and fast releases, that's an important feature. It also has the ability to scale up or scale down based on API driven. So using the AWS CLI tools, you can easily scale the cluster both up and down, and 0 is a possible number as well. So you can say, I want to scale my Thor cluster to 0, and you're not paying for any resources. The next time you want to use it, you say, I want to scale it to 360 nodes or some factor of 360, 24 or whatever. And a couple minutes later, you have a 24-node cluster. You do not have to wait for data to copy off of some other system. You do not have to redistribute your data. So for customers that might have very large data sets, multiple terabytes of data, that's a very attractive feature because the redistribution is a long process, or can be with large data sets. So that doesn't have to do. It's got a pretty low running cost compared to a traditional HPCC environment on HPCC and its continuous integration, continuous deployment. How easy is it to use? It's pretty easy. This isn't the entire thing. There's probably 3 or 4 more fields down here. You do have to have an existing VPC, so for customers that have VPCs, you can just take this and put it inside of your VPC, inside of Amazon, but you basically just fill out a few fields here and tell it what you want, you tell it how many nodes you want, and you're off and running. So here are some known caveats about it. One, we don't have any current production deployments right now. So we're in the phases, we've taken it through a couple of QA phases, and we've got it in some environments right now where they're testing it and running it beside traditional HPCCs to vet out any sort of problems that we have with it. And as we discover new issues, there hasn't been a new issue discovered in a little while, but as we discover new issues, we go in and fix those. It does have a limit of 8 exabytes of data storage, so if you have more than 8,000 petabytes, you're out of luck. It's got a limit of 175 active swarms of an existing hive. A swarm is an interesting concept. I don't have a whole lot of time to go into it right now, but you have the ability to, there's another script, there's 2 scripts. There's the Hive CloudFormation script, and then there's one called Swarm. And Swarm is just like Hive. The only difference between a Swarm script and a Hive script is a Swarm allows you to reference an existing hive. And what it will do is when you do that, it will go in, it uses the same EFS share. I'm going to go back here. If you notice, the swarm is on the right-hand side of your picture. It references the same EFS share on the back end, but when it comes up, it actually makes a hard link copy or a secondary inode of all the data that's in your Hive, and you have an additional running system. Let me give you an example of that. Let's say you have a production system running, and it's running your data and running your processes, and everything's going great. And you have a developer that wants to do ECL work. Pretty common scenario. That developer can go in, they can swarm a Hive, and what will happen is a new system will come up, a new Thor or Roxie, or both, will come up, and it will make a hard link copy of the data, not a true copy. You're not duplicating your data, you're not paying any extra money. You're creating an extra set of links. That developer can then, and by the way, that swarm can be on a completely different build of HPCC, a different platform build. And they can run their code, do everything they want to do on that data. They can delete all the data if they want to, because all they're deleting is that secondary inode. The production system's untouched, unharmed. And they can grab that ECL code, check it into some source code repository, completely shut down the swarm. Great, now we can release that code into production or platform or however you want to use it. So there's some interesting use cases about it. There is a limited HPCC AMI builds. We aren't going to release every release candidate of HPCC. We're not going to build an AMI for that. So when we have an official release of HPCC, we will put that into an AMI build, and we'll put those out on Amazon in the public repository. Maximum Thor size of 360 nodes. So if you need a bigger than 360 node HPC or Thor, it's not for you. Okay. Next one. I'm going to move through here. Whew. I have to move quick. Ultra Thor 2.0. Okay, so this is a traditional HPCC that's on physical hardware. And this was something that we put in place this year. We're building another one inside of Alpharetta. But here's some major changes. We started using SSDs instead of physical hard drives. We're bonding on the NICs to provide higher throughput than we traditionally have. Where the mirror on Thor, or the redundant part of Thor where it stores its data, we're putting that on low-cost storage. So we're taking that off of SSD. It's got a lower physical footprint, a lower electrical footprint, and a bigger room for expansion. Here's some of the hardware details for those hardware nuts in you. We have 1600 high performance, 1.2 SSD drives in there, 50 gigs bonded on the network to each server. There's 6,800 processing cores, about 51 terabytes of RAM in it, and comprises about 3 server racks. Here's some fun facts about it. Fun hardware facts. Total read and write throughput of 600 gigabytes per second. So it's about the equivalent of copying 100 full-length HD movies per second within the system. The total bisectional network bandwidth is 5 terabits per second. So for those of you that have ever downloaded World of Warcraft, it's like the equivalent of being able to download 31 copies per second of World of Warcraft. You can sort the entire Library of Congress, which is about 10 terabytes, in 7 minutes. It's half the physical size of our prior Thors, and we have better mean time between failure calculations on it. So going into Roxie Fusion, which is our next generation of Roxie infrastructure, and which is in POC right now. So part of the reason that we're doing this is because over the years, we've developed a habit of really relying on Roxie. It's a good thing. But that reliance has created multiple Roxie clusters over and over again for purposes of redundancy, purposes of isolation. Oh, we have to have batch clusters, and we have to have online clusters, and then we have to have cert clusters. And so all of that, every time we create a cluster, we add another 2 copies of data. And when we start to release data and we build data on Thor, and we're building files that may be 20, 30, 50 terabytes in size that we have to push onto these Roxie clusters, when you have to make 28 copies of that data, that takes time. And so we were having data releases that were taking upwards 24 plus, sometimes almost 36 hours of data releases. And so when we took a look at it, we said, how can we solve this problem? There were really 2 options. We centralized the data onto some sort of SAN type of equipment, but that has its other drawbacks, one of which is now the data is further away from the processors. And anytime you put data further away from the processors, you add latency. And latency is not something we want in Roxie. So what we started to do is we started to look at containerization. And how are we going to go about doing the containerization, being able to use containers to be able to still keep storage local on servers and be able to use containers to actually pass through those local storage and use those things that we actually learned from Hive as far as creating multiple inodes to be able to create isolation between environments, but still be able to combine and not have as many copies of data. So we're in POC right now. This is a little bit what it looks like. But these are kind of the approaches to be able to share data between environments to reduce duplication. So data is pulled once and released to all environments in seconds instead of hours or days. That's a very important feature. It's going to cut down our time to be able to release data into our production environments to literally be seconds. It's projected to reduce about 3,200 physical servers from our data centers, which is huge. We're hoping to improve the mean time between failure because now we're introducing RAID and bonding inside of our Roxie infrastructures. So we're kind of going down to a lot less nodes that are a lot more resilient from an uptime perspective. We're looking to save about $9 million in capitalization every three to 5 years on our refresh cycle. So it's a pretty big win as far as the financials are concerned. And then we're looking to be able to do more isolation, and this is very important to our business customers because it's always been a tradition that if you wanted a Roxie environment for us anyway in Risk, it was about $500,000 cost to create a Roxie environment. So when groups would come to us, QA groups and Thor groups and other people would come to us and say, hey, we need a Roxie environment because we really need to have our own one. Just for us, because we don't want to interfere with other people. A lot of times those business risks were weighed against the cost of the new system, and in a lot of cases, they were denied. So by doing this, we have the capability, it really doesn't cost us anything to add another set of containers across the Roxie nodes to be able to provide that isolation, and then we can still provide that isolation into the thing. And it's currently in a phase 3 POC. Matter of fact, I just got results about an hour ago. It's going really well. So anticipate that we'll be going full production on this towards the end of this year. So, questions?
John, 2 questions on your first part of the presentation.
Sure.
One is, why is the 360 limit on the number of nodes?
Great question.
And the second one is, why is the active-active configuration for Thor only limited to cross-AZ and not cross-region? Because the real redundancy is cross-region.
That's not true. Well, I disagree with your second point. But the first point is, why is it 360? The reason I chose the number 360 is because the number 360 has the most number of factors. There's about 24 factors to the number 360, and your scaling targets of your Thor nodes are factors of that 360. So it was a purposefully picked number to be under 400, which is kind of where we say the limit really should be for a Thor system, and then to create the most number of factors underneath 360.
We have operated for clusters with over 1,000 nodes, and it has worked perfectly fine for certain instances.
Okay.
So I'm just thinking that in a cloud scenario, having that kind of an artificial limit
There's
constrains a lot.
there's no artificial limit. Inside the CloudFormation template, there's a variable called max number of nodes. And if you change it from 360 to some other number that has a lot of factors, it won't stop you from doing it. We have found in our testing that when we go beyond 400 nodes, we get a point of diminishing returns that does not add up with the expense of creating the additional nodes. That's been our experience at Risk. But as we get improvements to the platform, as I continue to think, that may change, and we may look at it differently. In the second aspect of it, in terms of cross-region versus cross-availability zone, there are certain services that are region-wide at AWS, but an availability zone at AWS is actually it's a set of data centers that's located some 20 kilometers apart from each other, and availability zones are a single failure domain. Not to say that there hasn't been region-wide loss of certain services within AWS over the years. But generally speaking, when it comes to like the EC2 layer of things, it's generally, if they have had a loss, it's been contained within a single availability zone.
Yeah, there was a major S3 outage in a particular region.
Yep, and that's across service. That's across region. That's a region-wide service, S3 is. And that's a perfect example of certain services are cross-region, like S3. Other services like EC2 are per availability zone, and they're isolated and environmentally safe per.
And my point about cross-region being a better redundancy approach is because of the exact fact that in an availability zone, those data centers are like few kilometers apart. And that is a big risk when you talk about large corporations.
Yeah, okay, so in the case, yeah, and I mean, we can get into this discussion a little bit more offline, but there's two things. Obviously, you have to, from a cold DR standpoint, being able to get your data and being able to back that up off region is a good idea, and that's part of our business continuity plan. You know, Flavio outlines a lot of those on what that is. As far as uptime across multiple data centers, today risk relies on a multi data center, two data center approach to our DR capability, and we run active passive across it. And going into a multi-AZ, doing it multi-AZ within a certain region of AWS is no worse than that.
Well, even today, the two data centers are so far apart. Near Dayton versus Florida, I believe, right?
Alfred and Boca.
Yeah.
Yep.
So that's quite a distance.
And quite honestly, we've had cases where both data centers were down on us. Certain network routing problems that have caused both data centers to become unavailable for us at times. So not to say it doesn't happen, but the probability, it's a probability equation, it's calculation on that. Any other questions? Nope, okay, I'll let everybody go.
So I think that was ending with a bang. It was a very good presentation, nice, cool stuff, and I'm a kind of hardware guy too. I like systems and hardware, and this is a great new way to implement architectures on HPCC for scalability and high performance, and also make it efficient on the hardware that you have and cloud environments. Now, John, I do have to digress with you on the naming convention, on your way of picking names. So what's going to happen to the Hive 360 name when we move it to 720 or 1440? So we need to call it Hive X, where X is a variable. There you go. Anyway, so we got to the end of the day. Finally, after a long day, but with lots of good content, we have reached the end. So I want to thank you, our live audience, of course, and we'll adjourn for those. For everyone else in the room, thank you very much for being here. This was a great set of sessions and discussions and questions. And I hope that this continues throughout the year. Keep in mind there are a number of things that we are doing as activities to try to keep the engagement going. We have our Tech Talks every month. So please go to our portal, look at the Tech Talks. There is plenty of good content there. Don't hesitate to use our forums. Certainly contribute if you have anything to contribute, code, documentation, questions, whatever. Pull requests, that are always very good. And